All right, welcome back to Check This Out Mathematics. I'm Mr. O'Donnell, and we are currently doing some lessons on logarithms. Okay, and so if you like these lessons on logarithms from Check This Out Mathematics, then there we go. Then give me a thumbs up and put some comments down below. And oh yeah, subscribe to the channel. Okay, this channel right here. Check This Out Mathematics. Okay. All right. So now we are going to talk about a property that we have in logarithms, and that is called the change of base. Okay, not the ace of base. That's something else. That's a song from way back then. Okay, this is the change of base. Okay, and goes like this. Okay, if you have log base b of x, then that's the same as the log base a of x. Okay, the log base b of x is the same as the log base a of x, as long as you remember that it wasn't base a, it was base b to begin with. So we're changing from base b to base a. And so these two things can't be the same just as they are, because this is base b and this is base a. But if we divide by the log base a of b, now this is true, that the log base b of x is the same as the log base a of x, as long as you remember that you weren't doing the log base a, you were doing the log base b to begin with over here. Okay, and so this denominator here is the adjustment. Okay, think of it this way. Okay, suppose we have 7, and I say 7 is the same as 21. Well, no, 7 is not the same as 21. But if we adjust this number 21 and we divide it by 3, then it's true. 7 is the same as 21 divided by 3. Okay? And so that's what this property is saying, that the log base b of x is the same as the log base a of x, as long as you adjust this new base here and say, oh, but wait a second, we were not talking about base a, we were talking about base b. So if you divide the log base a of x by the log base a of b, the previous b, then this amount here, the log base b of x, is the same as the amount that you would get if you took the log base a of x and divided it by the log base a of b. Okay, so log statements are the same. The log base b of x is equal to the log base a of x, as long as you remember that it wasn't base a to begin with, it was base b. Okay, all right. All right, now let's actually show you where this statement came from, the change of base. Okay, the change of base. Okay, now remember our overall property of exponents and logarithms is this one, that if you have b to the n equals x, then that implies the log base b of x equals n. Okay? The logarithm is asking what is the power. So what is the power that makes b become x? And since b to the n power is x, then the log base b of x is n. Okay, and so that's the overall property of logarithms, that you can change from an exponential expression to a logarithmic expression, and then you can go back from a logarithmic expression back to an exponential expression, just by following this round trip, b to the n equals x. Okay, so we are going to start our change of base. Where did it come from? With our logarithmic expression here. We're going to say log base b of x equals n. Okay, now then, let's turn that around and say b to the n equals x. Okay, so we're going to follow that round trip, b to the n equals x. Let's show that properly. B to the n equals x. Okay, now what we're going to do is we're going to take the log of both sides. So I'm going to bring in a log here, the log base a, and the log base a. Okay, and so what I'm going to do is take the log base a of b to the n, and then take the log base a of x. So I'm going to take the log of both sides there. Okay, so let's bring that down. Okay, I took the log base a of both sides of this previous equation. Oh, that needs to be an equals there, huh? Okay, let's put in equals. Okay. Equals is one of the most powerful symbols in mathematics. It means the same as. Something is the same as something else. That's an amazing statement to be able to make. It's just like this line. You see this line? That line is the same as that line, right? You see, that line is the same as that line. And so those two dashes collectively give us the equal symbol. You know, it used to be something you'd have to write out. You would have to say the log base b of x is the same as, in words, is the same as n. But now we just put this equal symbol. And the equal symbol means is the same as, because that line, that dash, is the same as that dash. It means the same as. Somebody came up with it. It's pretty cool. Okay. Oh yeah, now back to logarithms. Okay, so we have we started off with our logarithmic equation here, and we changed it into an exponential equation. Okay. And then we took the log of both sides of that exponential equation. And now we have a power. Remember, the logarithm is asking, what's the power? So the logarithm is an exponent. Okay? See, there's the n is an exponent. N is an exponent. And right here, the log base b of x is an exponent. That's an exponent right there. And so this is a power to a power. Okay, the log base a of b is a power, and then b is raised to the n power here. So that's a power to a power. And when we have a power to a power, we can multiply our powers. Okay, so that means that the n can come down in front. N log base a of b equals log base a of x. Okay, the n can come down in front and be multiple. We're going to put a little multiplication dot there. Okay? All right, so we have a power to a power, and that means we can multiply our powers. The power n, and then times the log base a of b. Okay? All right, that's this property right here that we had earlier in our laws of logarithms. That when we have a power to a power, we can multiply the powers. All right. Now then, if we have multiplication on one side of the equation, that's the same as division on the other side of the equation. So let's put it over on the other side as division. So now we have n equals log base a of x over log base a of b. Okay, so I took this multiplication of log base a of b, and instead of it being multiplied by n, I divided it to the other side of the equation. Okay, so if it's in the numerator on this side, it's on the denominator on the other side of the equation. Okay, and now we have it. You see, because right here, n is equal to the log base b of x. And then here I have n is equal to log base a of x over the log base a of b. And so instead of putting n, I can just put this log base b of x and substitute. Okay, so we're going to take one more line on the next page. And say the log base b of x is the same as the log base a of x over the log base a of b. Okay? All right, let's put this all together. Log base a of b. There we go. I have to lift this up without touching my writing. Okay. All right. So over here, we started off at the top with the log base b of x equals n. And then the next step was to write b to the n equals x. And then we took the log of both sides over here. And then since we had a power to a power, the n would come down in front of the log base a of b. And so the n was being multiplied by the log base a of b. And so that means that on the other side, we can divide by the log base a of b. And since, so now at the top, n is equal to the log base of b of x. And at the bottom here, n is also equal to the log base a of x over log base a of b. And so then that means that, maybe we can do it like this. Can we do it like that? Okay, yeah. Balance it there. There we go. Okay, that's the full proof there. Okay, and so now then instead of writing n equals log base a of x over log base a of b, we go back to the top and say that since n is equal to log base b of x, then right here, we can put in place of n, right here where my finger there is, and I can put the log base b of x. Okay. Can you do it, Mr. Dunn? I'll hold this. One hand. Okay. It's not going to work. Okay. Okay. So right here we have n, and instead, see, it's hard to do this. Okay. So we need two hands. Okay. So n is equal to the log base b of x, and n is equal to the log base a of x over the log base a of b, and so then instead of n, we can put log base b of x. And the log base b of x is equal to the log base a of x over the log base a of b. Okay, so that's our change of base. Okay, put that x back. Okay, so this is our change of base property. Okay. It says that if we have a particular base for the logarithm and we want to change it to another base, that we can do that. The log base b of x is the same as the log base a of x, as long as we remember that we weren't doing the log base a, we were doing the log base b. So we have to divide it in terms of the log base a of the original base b. Okay, now okay. All right, now then, let's do some problems involving that property. Okay, so I have some problems here. Okay. All right, so now I want to evaluate. That's what we're doing here. We want to evaluate. Okay. Evaluate means to find the value of. Okay. So evaluate this example here. What is the log base 8 of 16? Okay, so what power of 8 is 16? Hold on a second now. 8 times 8, well, that's 64. If I have one 8, that's 8, and if I have two 8s, that's 64. I don't know what power of 8 is 16. Well, let's use the change of base. I bet that's a good idea. That's why we're talking about that. So let's choose another base. So the log base 8 of 16 is the same as, why don't we use 2? Log base 2 of 16. Okay, so this says the log base 8 of 16 is the same as the log base 2 of 16. As long as we remember that we weren't doing log base 2, we were doing log base 8. So we have to make an adjustment. We have to divide by the log base 2 of 8. Okay, so when we want a new base, base 2, we have to remember that the original base was base 8. Okay, so we changed the base. And now, let's evaluate each of the numerator and denominator. Okay, so what power of 2 is 16? Okay, I think we know that, right? Don't we know? 2 times 2 is 4, times 2 is 8, times 2 is 16, right? 2 times 2 is 4, times 2 is 8, times 2 is 16. So it's 2 to the 4th. That's 16. And 2 to the 3rd, right? 2 times 2 is 4, times 2 is 8. 2 to the 3rd is 16. 2 to the 3rd gives us 8. Okay? So the log base 2 of 16 is 4 because 2 to the 4th is 16. And the log base 2 of 8 is 3 because 2 to the 3rd is 8. Okay, well, I think we've done it. That the log base 8 of 16 is 4/3. Okay, now wait a second. You mean to say, Mr. Donald, that if I take 8 and raise it to the 4/3 power, that I'll get 16? That's exactly right. How do you know that? Okay, so that implies that 8 to the 4/3 is 16. Okay, and let's check this out. Why is that true? Okay. Remember that we have this property here that if we have a root, here we have the root of a, and this can be the square root of a if we know that this is the second root and the first power here. That's the second root, the square root. Okay, but we could then instead say we could have n here, and we could have a here, and we could have p here. So we could have a power and a root. Okay? And you know, what I kind of like to do is I like to not put a p there, but put a d there. Ooh, let's actually do it this way. Yes. Okay. You didn't see me do that because I got all thrown around. Okay. We're going back in time now. Okay. So, we don't have to have the second root and say this is a square root and the first power here. We could say that this is a to the n. Okay, we could say this is our power here, n. And then we could say d is the root. And sometimes we call it the root to the index. Okay, so d for index. Okay. Okay. And then we can rewrite this and say that the numerator is your power and the denominator is your root there. That's the way I want it. Okay? Okay, hey, I think that's somebody's name, D-A-N. Wonder whose name that is. Okay, and you can turn that around and write this as a fractional exponent, where the inside power here is your numerator, and the outside root is your denominator. Numerator over denominator. You see how that works? Okay. All right. Okay, what were we doing? Oh, yeah. So we had 8 to the 4/3, and that's 16. That's what we were saying back here. Okay, let's switch hands. Okay, we were solving this equation over here, or we were simplifying that. Log base 8 of 16. What power of 8 gives us 16? And we realized that 8 to the 4/3 is 16. And so let's see that that makes sense. After all, that's the #1 job of mathematics, is to make sense. Okay, so that 3 can be the root, and the 4 can be the power. Okay? And you can also write it this way. You can put the root here and the power on the outside. So that's the same. The power can be here on the inside of the root or on the outside of the root. Okay, so what's the 3rd root of 8? What number multiplied by itself 3 times gives us 8? Okay, that's 2. Okay, so the 3rd root of 8 is 2. And then 2 to the 4th, 2 times 2 is 4, times 2 is 8, times 2 is 16. It's true. Yes, math is true. Okay, that's why we like it. All right, so it is true that 8 to the 4/3 is 16. And so that's why log base 8 of 16 is 4/3, because 8 to the 4/3 is 16. 8 to the 4/3 is 16. Okay? All right, let's see. And this kind of goes back to what is logarithms. Don't they sometimes give us these decimal answers? You know, like, what is the log base 8 of 16? Well, if you put that in your calculator, you might get 1.333, and it would be repeating like this. And that's what 4/3 is, right? 1 and 1/3. Yeah. That's 1 and 1/3. That's the same as 4/3. Okay? And so it makes sense here that if you have log base 8 of 8, that's 1. And you have log base 8 of 16, well, that's 1 and some more. Okay, that's the whole idea of logarithms, is that we can realize that 8 to the 1st is 8. And then 8 to the 1st and a bit more is going to give us 16. And then if we do 8 to the 2nd, okay, that will take us to 64. Okay, and so log base 8 of 8 is 1. It just takes 1/8 to get us 8. It takes 1/8 and a bit more to reach 16. And then if we have 2 8s, 8 times 8, that's 64. So you see this nice progression there. Okay, awesome. goodness, Mr. O'Donnell, you talk too much and teach too long. Okay, well, let's call this another edition of Check This Out Mathematics. And we're doing these lessons on logarithms. Okay. And in this episode, we did the change of base property. And we solved this problem. And we did something more. We showed why it's true. And then it even made more sense in this progression. Gosh, the things we could know about math. Amazing. Okay, hey, if you're liking these videos, give me a thumbs up. Subscribe to this channel. Check This Out Mathematics. It's all one word. Check This Out Mathematics. That's all one word in the subscription. And oh, comments. Okay, signing off here, Mr. O'Donnell.